Hi doctor, my name is Sridhar Analalaki Chandrasekhar. My matric card number is F2582017. In this reaction, there are two main steps to form the final product, pentanal. First, we focus on building the carbon chain. We start with a terminal alkaline and treat it with a strong base, sodium amine in liquid ammonia. This removes the acidic hydrogen and forms an alkaline ion, which is a strong nucleophile. This nucleophile then reacts with bromo-10 and SN2 reaction, forming a new carbon-carbon bond. As a result, the carbon chain is extended to 5 carbons, producing an internal alkaline. Next, we introduce the oxygen using hydroboration oxidation. A bulky reaction like 9-boro-bichlorane acts across the triple bond in an anti-microbial manner, meaning boron attached to the less substitution carbon. After oxidation with hydrogen peroxide and sodium hydroxide, the boron is replaced by a hydrolyzed group, forming an anode. This anode quickly rearranges into a more stable compound, which is the alkaline pentanal. Thank you.
Hi, Assalamualaikum. My name is Muhammad Aikal Hayat and my metric number is F25A2090. The target compound is benzylic acetate and ester derived from benzylic alcohol and acetic acid. The synthesis can be achieved through the following 4-step sequence. Step 1. Friedel-Crafts alkylation. Benzene is reacted with methyl cycloride in the presence of a Lewis acid catalyst such as AlCl3 to introduce a methyl group onto the benzene, forming toluene. Step 2. Free radical halogenation. Toluene undergoes benzyl bromination using an bromocidamide under ultraviolet light. This selectively replaces a benzyl hydrogen with bromamine to form benzyl bromide. Step 3. Nucleophilic substitution. Benzyl bromide reacts with aqueous potassium hydroxide to produce benzyl alcohol. Step 4. Fischer esterification. Benzyl alcohol is then esterified with acetic acid in the presence of strong acid catalysts such as concentrated sulfuric acid to form benzylic acetate.
Hi everyone, I am Trisha. So in this video, I will be explaining how benzene is converted into different compounds from A to E. So first, benzene reacts with the bromine in the presence of the iron 3 bromide. So this is an electrophilic aromatic substitution reaction where the one hydrogen atom on the benzene is replaced by the bromine. So this compound A is bromobenzene. So next, the bromobenzene reacts with the magnesium metal. So this is a form of Grignard reagent where the magnesium is inserted in the carbon bromine bond. So therefore, compound B is phenyl magnesium bromide. So next, we have the Grignard reagent reacts with the formaldehyde followed by the acidic workup. So Grignard reagent add into the formaldehyde to form a primary alcohol. So the compound C is benzyl alcohol. And then after that, the benzyl alcohol is oxidized using PCC, which is a mild oxidizing agent. So the PCC means pyridine chlorochromate converts the primary alcohols into aldehydes without over oxidation. So compound D is the benzaldehyde. And then the last one is the benzaldehyde react with the ethylene glycol under the acidic condition with the removal of the water. So this forms a 5-membered cyclic acetyl, which is a protecting group for aldehydes. So therefore, compound E is 2-phenyl-1,3-dioxane. Hi everyone, so let's go through question 4 step by step. So first, the reaction begins with the bromine under the UV light, bromine and HV. So this causes the free radical bromination at the most substitute carbon of the methyloxane. So it's forming a bromalkane intermediate. So next, the sodium ethoxide is added. This promotes an E2 elimination reaction, removing the hydrogen bromide, so which will produce the 1-methyl cyclohexane. So in the second step, the alkene undergoes ozonolysis using ozone, followed by the reduction workup with the dimethyl sulfate DMS. This cleavage the double bond and open the ring, producing a linear compound that contains the N-aldehyde and a ketone functional group. So finally, the carboxyl compound reacts with the dimethylamine under the acidic condition, followed by the sodium cyanobromohydrate, which is NaBH3CN. This is a reduction amination reaction where the aldehyde and the ketone are converted into amine group. The amine intermediates are formally selective reduction in the final product. So therefore, the final product is NN and tetramethyl 1,6-hexane amine. That's all. Thank you.